All right. Welcome to the Physionic podcast. My name is, if you're not familiar with who I am, what this podcast is about, it's about learning your body from the macro to the macro. From the macro to the micro. My name is Nicholas Verhoeven. I am a PhD student in molecular medicine. And today I have the great honor of having a friend of mine and a classmate of mine, Abanoub Gad. So Abanoub and this particular topic is going to be talking about cancer. So Abanoub has a considerable amount of experience, at least researching in cancer. So I thought it might be interesting to get somebody who's more knowledgeable than I am on the topic of cancer, and certainly a big one that affects a lot of different individuals. So with that said, do you want to talk a little bit about your background?
Yeah, first of all, I don't like that you called me student, like you're putting us on the same plane. Cancer is way more important than muscles. Yeah.
I don't study muscles, but all right.
Whatever, Nick. I'm not paying attention to you. So I'm old. I graduated college in 2015 with a degree in neuroscience and psychology, like you.
I did not know that.
Yeah. I went on to a job at the Children's Hospital of Philadelphia, the number one children's hospital in the United States. And I worked on leukemia there, PH like ALL, if you're interested. And I also got my master's part-time while I was in Philly.
Oh, okay.
Yeah. After I graduated, they politely told me that the grant ran out. So I went on to the Dana-Farber Cancer Center, the number one cancer center in the world.
These are all from unbiased sources, as in the actual places he went to. They all told him they were number one.
Google it. So I worked there for a year, and now I'm here. I'm in the molecular medicine PhD program, doing more cancer stuff.
Okay, so your track is?
Cancer biology.
Cancer biology, and your master's was in?
Pharmacology.
Pharmacology. So you did psychology, neuroscience, undergrad, and then pharmacology for your master's, and now molecular medicine.
I like to keep it fresh.
Okay, good. So, like I said, we're going to be talking about cancer. I'm going to be asking Abanoub and different questions that we've kind of gone over. I've asked a lot of you guys over Instagram on particular questions you'd like answered. So I've got a few of those written down, and let's get right into it. So the first question that I wanted to ask was related to sugar. So a lot of people talk about nutrition having an impact on cancer, and I'm curious if you have any particular thoughts on how sugar can impact cancer, or even if it does.
So yes and no. Sugar feeds pretty much every cell in your body, right? And when I say sugar, I don't mean just like table sugar, like carbohydrates, right? Breads, pastas, table sugar. So sugar itself isn't gonna cause cancer. September of last year, they did a meta-analysis that included like 98,000 patients from the 80s up until 2018. And they found that having high doses of sugar in your diet isn't gonna cause cancer. But the side effect of having too much sugar, obesity, is what can sometimes predispose you to certain cancers. And there's something, it's difficult to study this in humans in particular, because you can't take a person, tell them, all right, for the next 6 months, I'm going to just pump you full of sugar.
Right.
And we're going to see if you get cancer.
Right.
So a lot of the stuff is done in rats or mice, or it's done through epidemiological studies where I collect a bunch of cancer patients and I ask them, hey, how much sugar do you eat on a regular basis? And
right.
So that's how a lot of nutrition and cancer stuff is done, because you can't do a controlled study to try and give people cancer.
So for the human studies, those were more like retrospective, as in they kind of just went back to figure out how much sugar content, and they didn't find any sort of correlation between sugar and cancer?
Yeah, no. The big correlation would be obesity. But say someone like me takes in a bunch of sugar, I get more obese, probably high chance cancer. Someone with all these fancy muscles, Nicholas. Eat as much sugar as you want. It's not going to make a tumor pop up on you.
Okay.
Yeah.
Okay. So interesting. All right. So certainly I've talked on sugar and its impact on obesity, and certainly it can be a contributing factor. It's certainly not the only factor. It's not like if you eat sugar, you're suddenly going to become obese. But that said, overconsumption of sugar is usually hand in hand with overconsumption of calories, energy intake in general, and then of course you have subsequent obesity after that. Okay, so the next question, and I know that you had a few reservations on exactly how you're going to answer this, but somebody asked about the estimated, so again, the keyword there, estimated ratio of lifestyle and genetics for actually acquiring cancer. What would you say to that?
Cancer is genetic, but not inherited in a sense. It's difficult to inherit cancer from your parents. In order, your genes come in two alleles, you get two chromosomes from your mom and your dad. The odds of you getting two cancer-causing alleles just through, your parents is low. Mm-hmm. Plus, your body has defense mechanisms in place to take care of that if you were to get it. So just pure genetics is hard. Usually they talk about acquiring a mutation throughout your life. So I'd say, if I had to estimate a ratio, lifestyle, I would consider just randomness of life it's definitely skewed towards that. Like, maybe I'm in the sun more often and I'm getting UV rays that are breaking up my DNA.
Right. Yeah.
So things like that, or I'm eating a lot of food that's cooked with high heat, like red meats when cooked with high heat can form some cyclic compounds that have been known to cause cancer. So things like that. So I'd say it skews towards lifestyle much more than it does genetic.
Okay. So on the genetic aspect, though, is it then more common for a person to have one particular gene from a parent that would be more cancer promoting, and then they have some sort of lifestyle event that then predisposes them to get cancer? Or are you saying that it's completely unheard of for a person to have two different genes that are both cancers from both parents?
Nothing is unheard of, in cancer. You'll find that everything has happened to someone once.
Right.
But no, they talk about this, like a two-hit hypothesis, where you have one mutation when you're born, but you got to acquire the second hit to your genome somehow to get these cells to start proliferating uncontrollably. So yeah, I'd say the two-hit hypothesis is what I'd lean towards.
Okay. And when it comes to lifestyle, I imagine that if you live next to a nuclear power plant or something along those lines, that probably has some sort of impact as well. So that's why it's so hard to really give an estimate on a specific ratio of, it's 20% this, 60% this, and 10%, whatever it is. It's hard to actually say, it's exactly this, because every person has different lifestyle factors, and of course their genes themselves are going to be completely different from person to person. So there's a lot of different factors essentially. So the estimation is incredibly difficult. So let's move on to the next one. So in general, can diet, so we talked about sugar specifically, but as a whole, can diet positively impact cancer? Or can it, let's just say, can it have an impact on cancer in general?
It depends, prophylactically, before you get cancer, definitely, you can eat things that will throw off signaling in your body, throw off glucose levels, insulin levels, things like that, that will cause cancer. But once you get cancer, there isn't really a diet or a magic pill or something you can ingest at home that will make it go away. You might be able to, lessen certain symptoms or lessen some side effects from drugs with diet, but once cancer is diagnosed, there isn't really any evidence that you can change your diet and get healed. And there's unfortunately a lot of YouTube pages or websites online that are selling people PDFs with diets on them. I cured pancreatic cancer with this simple 12-week diet. And it's out there. Yesterday I saw a YouTube channel of this dude who had 7 PhDs.
Wow.
And a doctorate in like naturopathic medicine,
Always good.
which is not a thing. And I like Googled him. I looked him up on LinkedIn. All of his degrees are from Panama, from a school that I could not find exists. But he has a very popular YouTube channel, and you know, cancer is, one, it's not understood well, and two, the one thing people need more than anything, I think, is hope, and that's what a lot of these websites sell, like hope. But scientifically, I couldn't find any evidence that once I get cancer, I can change my diet and it can be curative without some sort of medical intervention, be it surgery, chemo, or immunotherapy, or some of these new things that are coming out now.
And why do you think that nutrition doesn't have that impact? I guess let me reframe the question. Like, what makes cancer so incredibly difficult to treat?
Well, one, it's heterogeneous. It's very different from person to person. You hear things like staging of cancer, like I have stage 2 lymphoma or something,
right. Yeah.
Or stage 4 breast cancer. So it's different from person to person. And based on all these differences, you treat it differently, and ultimately your body finds a way to maintain it. Like, what's the word? It starts with an H.
Homeostasis,
right?
Homeostasis,
an important word. I'm in a PhD program. I should know homeostasis. Your body finds a way to maintain homeostasis. Like, you hear this thing about some people will stop eating sugar when they get cancer because I will starve my cancer cells. But to be honest, like, your glucose levels don't really change much. If your body can throw out some insulin, it can lyse some glucagon. It can go through gluconeogenesis, like making sugar fresh when you don't intake sugar.
Yeah.
So it's your body finds a way to maintain stability. So there isn't much you can do at home to drastically change the environment of your body to try to throw off your cancer. And your cancer is very smart. It can get around some of these things. Like, its metabolism, is different. It can hoard resources from your body. So yeah, I can see nutrition having like positive. Science sees that nutrition has positive impacts on cancer. So if you maintain a good diet now, then the chances of you getting cancer are decreased. But someone who has stage 3, I don't know, like pancreatic cancer, no, don't start eating parsley shakes. You need to go to a doctor.
Right. Right. So with nutrition, you touched on it, how cancer can be really devilish just because it can adapt. It's incredibly intelligent. Like, it just knows how to use its environment to its advantage. And I know of a subject, we didn't even talk about this necessarily. Actually, you've got it right there, the Warburg effect.
Yeah, Otto Warburg.
Yeah, so can you talk a little bit about what that is?
Otto Warburg, definitely top 5 Germans in my book. He was a German in the early 1900s who had some cells, some cancer cells and some regular cells, and he saw the cancer cells were eating way more sugar than the regular cell. Basically this idea that the cancer cell is hoarding sugar to itself became known as the Warburg effect. And his idea of like why this was happening was incorrect, but today we know that what the cancer cell is able to do is it can hoard the sugar, and instead of going through the mitochondria, the powerhouse of the cell, instead of going through the mitochondria, your cancer cell actually makes lactate to break down the sugar for energy, which makes way less energy than the mitochondria, because the mitochondria is the powerhouse of the cell.
Naturally.
So the reason the cancer cell is doing this, like, why should I take less energy, and not go through my mitochondria, which can make like 18 times the energy of the lactate system, is because there's no feedback inhibition. So the mitochondria has systems in place to tell itself like, oh, I have enough energy. I'm going to feed backwards and tell myself, okay, we can start storing some of this stuff. I don't need to make any more energy. Mm-hmm. When you go through making lactate, you get less energy, but it can go on forever. And it helps maintain some carbons. So sugar is ultimately some carbon that gets broken down into energy. And if I can maintain those carbons, I can use them as building blocks for other things so the cancer cells can proliferate and grow and make more. So they avoid the mitochondria, even though they have mitochondria and they function and they're good. And that's the Warburg effect. It's how cancer cells eat.
So it's largely a shift in metabolism then from what other cells might have or what would be kind of normal. And along with that, you mentioned the heterogeneity between different cancers. I mean, if you're looking at like a glioblastoma compared to, I don't know, some other cancer, the metabolism between those types of cancers could be different, but also within just the glioblastoma family of cancers, because there's such heterogeneity, even just within that one type of cancer. So the idea that people use, oh, well, I cured brain cancer because I avoided X food. Yeah. It doesn't really pan out even within that one cancer, because that one cancer can be so different because of different mutations and all kinds of different factors that can make it so different from really just every other cancer that is within that arm of a family of cancers. I don't even know if I'm explaining that correctly, but
I get it.
Okay, you get it. So diet can have an impact, but it's more of just kind of leading up to the point. Once you have cancer, it's not going to have. Definitely talk to a doctor. That's like the number one thing, and having good nutrition is certainly important, no matter what, whatever state you're in. If you're not getting any vitamin A for the rest of your life, that's a problem, and that's just a problem in general. It doesn't have to be necessarily because of cancer, though.
Yeah, I was in class the other day, and the professor put up a slide, and he was like, "What causes cancer?" And the first thing on the slide was breathing. You breathe, that's oxygen. Oxygen can make oxygen radicals. It can interact with things. It can cause inflammation. Whatever. I think we don't. If you were to ask a doctor, he'd tell you everything like in moderation, because everything can cause cancer. Like coffee, black coffee, you have a cup a day, it's supposedly healthy. You have a gallon a day, it's carcinogenic.
Yeah, right.
The sun, I love the sun. If you stay out in it too long, you're gonna get UV radiation. You might get cancer. It's sugar. They did that study with the rats that we were talking about earlier, where they gave rats the equivalent of something like 400 packets of Splenda, and they got cancer. One packet of Splenda a day is not going to cause cancer.
Right.
400 packets a day, it's going to cause cancer.
Right.
So I just think doing things in moderation will decrease the chance of you getting cancer. Like, you don't need a steak every week or every day. You can have a steak once a month. You'll be fine.
Yeah. And and that's totally true for something other than cancer. I've spoken on this before. If you drink 12 gallons of water, you
get water poisoning.
That's not moderation. You're going to die. Like, it's simple as that. Like, going to any one extreme it's just poor practice in general, especially when it comes to cancer. But even outside of that realm, it's certainly true as well. And you touched on this already, but talking about the Splenda experiment, but also we talked on sugar, we talked on nutrition. What about artificial sweeteners? What do you know about that? How does that affect cancer, or does it?
Yeah, so this is one of those like cancer myths that came out in the 70s. Basically, a lab in Italy came out with this study saying, hey, we gave some rats saccharin, and these rats developed tumors. And saccharin at the time was in like toothpaste, you know? And Canada banned it completely. The US started putting like labels on things like this contains like cancer causing, yada, yada, yada. So, years later, the FDA is looking into this again, and they find that mechanistically rats digest saccharin different than humans.
Shocker.
Yeah. So if a rat takes it in, it's gonna cause cancer because there's a byproduct there that humans just don't make. We take it in, it's broken down, I think, into like phenylalanine or something pretty inert. and it just goes on its merry way. So in 2010, I think Canada no longer bans it. It's currently in your toothpaste, probably. Like, look through. You're fine. No one, you're not gonna die. So after doing a lot of like epidemiological studies and better controlled like rat studies, you find that it doesn't really do much for humans. It's not cancer causing. There's also aspartame, the thing that's in like diet soda. That one's supposedly also like very cancer causing. The same lab it's the same lab that came out with this study, and the FDA came out and said like this was a badly designed study. They found that you can make a rat get a tumor with 16,000 parts per million aspartame or Splenda. They did it with both.
Yeah, they did it both.
Yeah, and do you know what 16,000 parts per million is? It's 420 packets of Splenda a day. And that was the lowest like dose that they saw an effect. So yeah, artificial sweeteners don't cause cancer, but a tub of artificial sweeteners probably gonna cause cancer.
Yeah, right.
Yeah.
And that's actually not the only study my very first article that I ever wrote for Physionic. At that point, it was called OmniFocus Fitness, but now Physionic. I know. That I did it on aspartame. So I read 30 different studies, and some of them were on cancer, and there were other cancer studies that looked at obviously aspartame's link to cancer, and they literally, if you extrapolate it out in terms of the amounts that they took in, you're taking in kilograms of aspartame, which is insane because aspartame is 200 times sweeter than just regular sugar. So you need so much less. So to think that if you're consuming kilograms of regular sugar, that's already just asinine. But then on top of that, think aspartame, which is 200 times more potent. I mean, it's absolutely insane to think that in physiological levels or any sort of applicably nutritious levels that you're going to be consuming that much aspartame. It goes exactly back to our previous point that you're overdoing it. It's not even overdoing it. It's just like you're killing yourself. Like even beyond cancer, you won't even have to worry about cancer because you can't even physically eat that much of these artificial sweeteners.
Yeah. Also, this is like a fault of science. Say I do a study and I find that Splenda doesn't cause cancer, right? And I'm sure hundreds of labs did this study back in the 70s, 80s when these things were getting popular. You can't publish that anywhere. No one wants to publish like, great, you found nothing. So the thing that does get published is this radical like, these rats have prostate cancer, everyone's gonna die, like this is the plague.
Right.
That's what gets published. But if you look at the FDA and like the EU's version of the FDA, they did a study of 500,000 people over decades, and they didn't find any sort of correlation, let alone causation between Splenda or artificial sweeteners and cancer. So have your Splendas. My family all has diabetes. No one has cancer. They love Splenda. It's fine.
Yeah, it's perfectly fine. Okay, so the next topic, somebody asked me about resistance training and its impact on potential cancer risk or any sort of relation that it might have. Do you know anything about that?
Yeah, so I tried every search I could to see if anyone's ever looked into this, and I couldn't find anything. Generally, for people who go through hormone therapy for prostate cancer or ovarian cancer or something, they go through a 12-week regimen of resistance training to strengthen their bodies and make sure they're not losing too much muscle mass. But as far as resistance as a prophylactic for cancer, I couldn't find anything. Sounds like a nice thesis proposal.
That's true. Let me ask you about something else then and I'll try and relate it back to this. Reactive oxygen species. So do you know of any evidence that reactive oxygen species induce cancer or have some sort of impact on cancer?
It's the same as before. Yes, in a sense. If you have reactive oxygen species, you can definitely develop a predisposition to certain cancers, but the way these studies were done is I'm not about to give someone a bunch of reactive oxygen. You do your best with animal studies, and if the dose is high enough, then potentially.
Okay. So going off that, if that's just a factor, and it may be a major factor, maybe a minor factor, we don't know, but with exercise in general, if that's resistance training or specifically aerobic exercise, there's actually a greater capacity. During the actual exercise session, we actually see increases in reactive oxygen species, actually pretty sizable increases in ROS.
That's why I don't exercise.
Yeah, but on the back end, so don't listen to him, because on the back end...
I don't exercise either end.
On the back end, what you'll find is that our ability, the cell's ability to buffer ROS, reactive oxygen species, is actually considerably enhanced. So if you can make an argument just from that one sliver of a point that resistance training, but more specifically cardiovascular exercise, would lead to a decreased risk of cancer, you could maybe make that argument. I'm just throwing out the information out there because we didn't have anything else to talk about on that topic, because there aren't going to be that many studies that are going to look at exercise and its impact specifically on cancer. That's just what I've investigated in the past.
How would you even do that study?
Do
you just get some doughy individuals all right, half of you are going to work out and we'll see if you get cancer down the line. 80% of cancer is diagnosed post 60 years old.
Oh, I did not know that.
Yeah. So who's the target subject for this study? Like old people who lift?
Right.
Because most old people aren't doing resistance training the way a young person would do it.
Yeah.
I don't know,
that's true. That's totally true.
Yeah.
Before we move on to the last question, could you talk about what reactive oxygen species are? Because that's probably something that not a lot of people are all that familiar with.
Yeah, oxygen,
just kind of generally.
Oxygen is everywhere. And whenever oxygen has electrons that aren't paired with anything, right? Mm-hmm. Everything likes to have 8 electrons around it to be nice and stable. When oxygen doesn't have that, it becomes reactive, and it will start, making connections with whatever it finds around. And that can lead to inflammation, and it can lead to your immune system reacting to it and all this other stuff. So yeah, that's why people say take antioxidants. Mm-hmm. They're against oxygen, so you don't make an excess of these oxygen species.
Right. And you can get that from your nutrition, and you can certainly get that from, as I said, exercise buffers that just by increasing some of those antioxidant abilities within your cells. However, and you mentioned this before, that if you overdo it on antioxidants, you're also causing a lot of damage. Not necessarily cancer, although it's certainly a possibility as well, but also in other areas. So ROS, reactive oxygen species, are also used as signaling molecules. So you kind of have to have some of them. And again, it goes back to our previous point, but you don't want too many of them. You don't want too little of them. You have to have them right in the middle. And your body's really good at keeping them right in the middle, as long as you're not going off the deep end, smoking, drinking, not keeping up with your nutrition, obesity, diet, all these different things.
Did you just point at me?
What? You mentioned obesity earlier, so
all right, calm it down. The BMI of 29. It's one away from obesity.
All right, so let's move on to the last question. People sometimes say that we have made no progress whatsoever as a scientific community towards curing cancer. Some people might even say that the government is holding back the cure for cancer. What would you say to those people?
Definitely.
There we have it. That's what I've got for you on the Physionic podcast.
No. Obama took it with him. The government's not hiding the cancer cure. Cancer is not one thing. Cancer is an umbrella term for over 200 different diseases. For the government to hide your cancer cure, they need to have hired hundreds of thousands of employees built manufacturing plants to get these drugs made, and all of that while academia not having caught up to any of these 200 drugs. They're not hiding it. Also, you'd make way more money by selling this cure than keeping it. Like some leukemias, for example, are curable, very curable. As of like 2010, if you catch Hodgkin's lymphoma early enough, it's 100% cured. It costs $500,000, but it's curable, right. And your insurance probably covers it because it's leukemia or lymphoma.
So what about progress? Do you think that we have made any progress?
So it's the progress kind of looks like this. What is this, exponential? So in the beginning, we made very slow progress because you had two methods of treating cancer. From way back in like Renaissance time, if you had a growth, what do? You cut it out,
Just
right?
Cut it out.
Right. So surgery was always the first line of defense. Then we came up with chemotherapy, which is just a bunch of different drugs that are toxic to cancer cells and like just your regular cells. But in the early 2000s, you had this revolution of targeted therapies, where now I can get an antibody that's specific to something on a cancer cell that's not on my regular cells. And in 2010 and like onwards, you have this huge discovery of like immune therapy, where I can teach my immune system to target the cancer cells. And this is how a lot of leukemia is treated, for example. Or now we can do bone marrow transplants that aren't 100% matches anymore. So a lot of people who get these blood cancers, cured. And now we're even engineering cells, and we're coming up with like peptide drugs. So at the beginning, yes, it was very slow. In the 70s, if you got Hodgkin's lymphoma, your 5-year survival chance was something like 50%. Today it's 99. So we've made, for a lot of different cancers, we've made significant progress. And given the state of technology and how fast technology is moving today, it's getting better and better much faster than it was before. So no, I think we've definitely made progress, but I think it's just human nature to focus on the negative.
Well, that's true. And also, if you without even taking any of those points to heart, you can just look at something as simple as our population is increasing, our obesity crisis is increasing. You're going to have higher cancer rates. It's as simple as that. You're just going to have more people that have cancer just because the population has increased and because of all these other factors that we've talked about. So even though the technology is getting better and better and we're curing more people, we're extending life expectancy for a lot of cancer patients, that doesn't get as much credit or gets kind of lost in the wash of the fact that there are so many people that are getting cancer. And that's just because we're not leading the healthiest lifestyles necessarily, at least in the United States. I know, he's
How
shocked.
Dare you?
Shocked, I know.
How dare you? McDonald's offers grilled chicken. What do you want?
So with that said, is there anything in specific that you wanted to make sure that you get out there about specifically cancer that you feel like people are getting wrong or people are not understanding correctly?
I just say watch your sources. There's so much misinformation because it's such an easy way to take advantage of people. Like, you're at your most desperate moment, probably a loved one or someone is potentially going to pass away. So there's people out there who unfortunately try to take advantage of you, and there's people who are misinformed who will accidentally take advantage of you. They truly believe a parsley milkshake is gonna cure your adenocarcinoma. It's not. I'm not saying blindly listen to two graduate students. We acknowledge we don't know much about anything. We're just good at Googling these things. But be skeptical. Look at your sources. Make sure you're look at articles and look at scientific literature, and try to, if you don't understand it, talk to your doctor. Bring them an article. Tell them they'll be happy to tell you oh, that's what this means or whatever. Just be very critical and don't take things at face value. If you were to read that article from Italy a few years ago, you'd say, okay, Splenda causes cancer, but you do a little digging, you ask some questions, eventually you'll find the truth. So I think skepticism is very important when it comes to matters of cancer or most things. You don't want to just be an idiot.
That's true. Yeah, skepticism is incredibly important. And if you do have a doctor that if you bring them an article or something, I mean, I get that, especially in the United States, doctors don't have that much time, but you should get a sense of your doctor and get an idea that you should get a doctor who wants to help educate you and isn't going to say, 10 minutes are up, sorry, get the boot, get out of here. Your health is incredibly important, and it's probably the most important.
Talk to your local grad student. We love to feel important.
That's true.
Nobody talks to us all day. We're in a lab. We talk to same three people every day. So.
Or we just whisper to ourselves.
Yeah, I talk to my lab animals sometimes. Name them. It doesn't necessarily have to be a doctor. Find someone who can read this scientific language if you need help and see what they tell you.
Yeah, true. Okay, well, with that said, that's everything that we've got for today. Hopefully you found the podcast informative.
And if you want a Nick's Abs podcast from now on where we talk about scientific memes, just hit that like button, subscribe, get our merch. Do we have merch yet?
We do not have merch.
All right, we'll get merch.
With that said, hopefully I have the pleasure of speaking with you next time. Maybe we'll see if Abanoub's up for a round 2 in the future.
I love myself, and I will never not want to hear my voice recorded. So
brilliant. Okay, have a good one, guys.